everyone, welcome back to the Pre-Calculus 20 videos. And this here is part 2 of our first video looking at graphing quadratic functions that contain absolute values. So in the first part of this question, we were looking at an absolute value function, and we had found the x and y intercepts. So now what we need to do is, we need to sketch the graph of that actual function. And if you notice here, I gave you guys a pretty good amount of space for your quadratic function. And we're going to do that, and I gave you a lot of space there, or a lot of different columns and rows here, just for a specific reason. Just because there's a lot going on when we graph an absolute value function. So there's some important things that we need to have in our graph. So the first thing that we should do is, I want to put our x-intercepts in our table values. And so where those ones go is I'm going to put them on the second from the top and second from the bottom. So I'll put our first one here as -2 and 0. So those are one of our x-intercepts that we found in the last video. And then we also need to have 4 and 0. That's going to go down here closer towards the bottom. It's going to be second from the bottom. So we have 4 and 0 here. Another point that we really need to have in our table values is our vertex. And if you guys remember all the way back from chapter 4 and chapter 3, we looked at graphing quadratic functions in standard form. So essentially what we can do is we can apply the same concept here using this function, just without the absolute value symbols. And if you guys remember, to find our vertex, we're going to use the formula x is equal to b over -2a. So using our values here, so we have a, b, and c here. So our b value is +2. So we have 2 over -2 times a, which here is -1. So -2 times -1 is +2, and 2 divided by 2 is 1. So that means our x value for our vertex is going to be at +1. And that one there is going to go in the middle of our table values. So that's going to go right here. Then what we need to do is we need to find that value, the y value for that function. So it's up to you if you just want to fill in your x values first, or while you're putting in each value, you can go ahead and find your y value. But actually what I'm going to do is I'm just going to fill in all my x values first. I can find the y values afterwards. So then what I want to do is I want to fill in the rest of my table values. And so one other thing that I might also do is I might also put maybe something else that we calculated. So in the first video, we also found our y-intercept. So our y-intercept, I'm just going to scroll back up to our work here, was at 0 and +8. So that's already a point on our graph. So why would we want to do more work when we already have a point already done? And that would fit right here in our table values. So that was at 0 and +8. Then what we can do is, from here on out, we can just choose our own values. And so we kind of want to make sure that they kind of fit the trends of our data values here. So we want at least one point above that, or below that first x-intercept. We want one above it, just so we can see how that W shape of your graph, so you know how our values, or our graph should look something like this. We want at least one point on the left side, one point on the right side. So we'll go one above and one below. Then just to also see how this graph is behaving, we're also going to put our vertex, which will be right here, and then one value to the left, one value to the right. And what I might recommend is, if we already chose 0 here, I might want to choose the same distance away from this vertex. So this is 1 away to the left. We want to go 1 to the right. So we're going to add 1 here, so we should get +2 for our value here. And I do that for a specific reason, because if you guys remember, with your vertex, every point after that should mirror, or should be a reflection of each other. So we should get the exact same y value for 2 here, assuming we did all of our work right in terms of our y-intercept, finding the vertex, so on and so on. So as long as we did our work right, this should give us our same y value. And then so what I might do here afterwards is I need to do one above and one below. So one above, one below. And for that one there, it's really up to you if you guys want to go up and down by one value or up and down by 2 values. If you really want to see a good chunk of that, I guess that spread of data, you might want to go by 2. That way we can see a really good spread of that. So we can go up by 2 here, so we'll add 2 to 4 to get 6, and we'll go 2 below to get -4. So now that I filled out all of my x values, now I can go ahead and actually start finding those y values. So I'm going to put each of these into our equation here, and I'm just going to scroll up just a little bit so I have a little bit more room. So when x is equal to -4, we're going to plug it into this function here. So the absolute value of negative, so it's -4 squared plus 2 times -4 plus 8. -4 squared is 16. We have a negative symbol out there, so that's a -16. 2 times -4 is -8, and plus 8. And we can add and subtract those values. So -16 minus 8 would be -24 plus 8 again would give you the absolute value of -16 again. And the absolute value of that is just positive 16. Now scroll down to see the rest of our table values. So now here we're going to go with our vertex. So this one here was when x was equal to 1. So nice and important there. So plug in 1 into our values. So you have the absolute value of -1 squared plus 2 times 1 plus 8. So that's equal to the absolute value of -1 squared. So 1 squared is 1. So you have -1 plus 2 times 1 is 2 plus 8. Then we're left with the absolute value of -1 plus 2 is +1, plus 8 is +9. And then the absolute value of 9 is simply just 9. Do the same thing here for x is equal to 2. So the absolute value of negative, so it'd be 2 squared plus 2 times 2 plus 8. 2 squared is 4, so we have -4 plus 2 times 2 is 4 plus 8. So we have the absolute value of -4 plus 4 is 0 plus 8 will be the absolute value of 8. And then we get just positive 8 as our answer. And so remember, as I said here, if we did our work right, this should be the same y value as the opposite value, or the one across from our vertex. So here we have 0 and 8, we have 2 and 8. So here, this is a really good indication that we're doing our work right so far. And then we can do our last one here is for when x is equal to 6. So here we have the absolute value of -6 squared plus 2 times 6 plus 8. So 6 squared is 36. So you have -36 plus 2 times 6 is 12, and then plus 8. -36 plus 12 would give you -24 plus 8 is -16. And the absolute value of -16 is simply just positive 16. So now that we have all of our x and y values, now we can go ahead and start graphing. And in order to start graphing, we first need to look at labeling our x and y axis. So here, we're going to start with our x-axis. And the biggest value we need to reach up to is 6. And for our y values, we need to go all the way up to 16. So we're going to have some pretty big numbers there. So here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 lines. We need to get all the way up to 6. So we'd probably want to go every line would even be equal to 1. And I'm just going to label every second one, just or else it'll get a little bit cluttered. I'm also going to go in the negative direction as well. And then for our y values, we need to get all the way up to 16, and there are 10 lines. So in this case here, we might need to go every line is 2. And so once again, I'm only going to label every second line. So now that we've labeled our x and y axis, now we're ready to go. So now we can go ahead and start graphing our values. So our first one here is at -4 and +16. Then we had -2 and 0. We had 0 and +8. We had 1 and 9. Then we had 2 and 8 again. 4 and 0. And then we had 6 and +16. So then what we can do here is, it's up to you. You guys can create, as you guys start to practice this, you guys might come up with your own little ways that you would prefer to graph. But so as you remember, we should almost have this W shaped over here, where it almost does like a really weird kind of curl back at that little middle part of that W. So you can almost start by drawing that first if you like. So remember, nice and smooth around that vertex. And then what's happening is it's going to shoot in the opposite direction, going out and up to that opposite value. And so there we have the graph of an absolute value function, and specifically the graph of an absolute value function that was a quadratic function. So here we see that it creates a W shape where it's very sharp turning at our x-intercepts, and then it's a nice smooth curve around that vertex. And so just as a note here, you guys can kind of see the shape of the graph and even determine whether or not it is opening up or down, normally from the equation, because we know that our a value was negative. So it should tell us that it's opening down. But when we're looking at our table values here, when we're looking at the one value above and one value below, we see that we actually have to apply this absolute value because our answer was negative, and we made it positive using that absolute value. So you can tell where it's reflecting. So maybe our original graph would have went somewhere down here. It would have continued that direction. So you can kind of tell, even just from the table of values, that where our reflection was happening, just because of where we had to apply that absolute value. So where it was positive in the first place is where our absolute value didn't change the actual answer. So this little middle part of that W stays the same regardless of if it's absolute value or if it's not. So that is everything here for this video. So if you guys have any questions, make sure to come see me in class or text me on Remind 101. And thank you guys so much for watching.